All right, in this video, we're going to learn very specifically how to use derivatives to find the equation of the tangent line at a point on the function. So again, just to kind of give you a little bit of a picture idea of what's going to happen here, if we have a function, and let's graph a cool looking function here, and I said, okay, here is a point right here on the function. What is the equation of the tangent line at that point? So there's this blue tangent line, right? This is the tangent line at that point, and I want to find the equation of that line. How do I do it? Well, that's exactly what we're going to cover in this video. So let's walk you through it here. So to find the equation of a tangent line to a function at a given point, you only need two items. First, you need a point. Well, heck, we're already given a point, so if I'm going to talk to you about a point, I'm going to give it to you, so you will have your point. Then you need the slope. Now, how do you find the slope? Well, that's what a derivative's for. So you're going to find the derivative of the function, a formula to find the slope of a tangent line, right? That's what a derivative is. It's a formula to find the slope. So once you have the derivative, a formula to find the slope, you can then use it to get the slope. And once you have the slope and you have your point, then you could write an equation in point-slope form. So your point is x1, y1, and I'll give you that. Your slope you'll use the derivative to find, and then you could plug those into this equation to get your equation of the tangent line. Now, I love point-slope form because it's so easy to use, so that's why I recommend using it. All right, let's dive into an example. So we have a function 2x squared minus 7, and we want to find the tangent line equation at -2, 1. Now first, it is worthwhile to just check that this point is on the function. So if I take -1, what am I talking about? -2, and I plug it into the function, I better get 1. So -2 squared is 4, 4 times 2 is 8, 8 minus 7 is 1. So this does confirm that this point is on the function. So let me remind you, derivatives only work if the point is on the function, so you got to make sure you understand that. All right, so how do I find the derivative? Well, I'm going to go ahead and differentiate. I'm going to use limit process to find the derivative, and it's a very, very specific process that all starts off with this, hopefully to you, a very well-known formula at this point. All right, now here I go. I'm going to plug in x plus h. I get 2 times x plus h squared minus 7. I'm then going to subtract my original function, 2x squared minus 7. Now notice, since it's a binomial, when you subtract it, you do need to put a parentheses around it because I'm going to have to distribute that negative sign. All right, all divided by h. All right, so in the numerator, I already know what 2 plus h squared is. That's x squared plus 2xh plus h squared. So now I just got to distribute 2. So that's going to give me 2x squared plus 4xh plus 2h squared minus my 7. Now I'm going to distribute this negative sign back here. So I get -2x squared plus 7, all divided by h. All right, now remember, I'm ready to go when I can get this h in the denominator to cancel. But the only way you can get that h in the denominator to cancel is if there is a factor of h on top. So let's see here. What's going to happen? What's going to happen? Well, the 2x squared and the -2x squared is going to turn into a 0. Dust in the wind. The -7 and the +7 are going to turn into a 0. That's just dust in the wind. So after all the dust settles, all that's left is 4xh plus 2h squared, all divided by h. Well, I still can't cancel out any of these h's yet because they're not factors. So if I factor out an h from the numerator, then I will be able to officially get the h in the denominator to cancel. So now I need to go back and rewrite my limit. I'm going to find the limit as h approaches 0 of this new and improved function 4x plus 2h. Now, really, that's this, right? All of that is this. I just did a lot of cleanup work to make it look nice. Now when I plug 0 in for h, I get 4x plus 2 times 0. Well, that's just 4x. So there is my derivative. The derivative of my function is 4x. All right, so what do I need to write the equation of the tangent line? Well, I already have a point, negative 2 comma 1. That's easy. Now I just need the slope at that point. Well, that's what the derivative is for. So to find the slope at negative 2, all I got to do is plug negative 2 in, and I get negative 8. That's awesome. So now I know my slope is negative 8. And now I'm going to write the equation of my tangent line. It is y minus 1 equals negative 8 times x plus 2. Now remember, the formula is x minus, but when you subtract a negative, it turns into a positive. So there is my equation. And you know what? I'm just going to leave it like that. No one ever said it had to be in point-slope form or slope-intercept form or anything like that. So I'm just going to leave it like that. Now, obviously, I could clean this up. I could distribute the negative 8 and then add the 1 over. But hey, I don't need to do that. I'm just going to leave it in that. All the problem wanted me to do is write an equation, and I wrote it. All right, let's try one more just to really hit home the idea here. All right, so I have a point. And like I said, I always like to do this first, like just to make sure it's on the function. So if I plug in 5, I get 3 over 5 minus 4. That's 3 over 1, which is 3. All right, so this is a point on the function. Because remember, if it's not on the function, derivatives don't work. So now what I need to do is I have a point. Check. Now I just need my slope. Well, I can't find the slope of the tangent line without a derivative. So I'm going to go ahead and use the limit process. This is how you differentiate using this very, very well-known formula. At least it should be well-known to you. And now I'm just going to find the derivative. So I'm going to plug in x plus h, so I get x plus h minus 4. Oh, I almost wrote a plus sign. It should be a minus sign. So minus the function, which is 3 over x minus 4, all divided by h. Now, you know, every teacher might teach you how to simplify this, but I'm going to teach you right now how I simplify it. I rewrite the top. And the first thing I hate is I hate double fractions. So instead of dividing by h, I'm going to multiply by its reciprocal, 1 over h. And that's the h that I'm hoping is going to find a way to cancel somehow. So my next step is to, follow, what a lot of kids want to do is they want to distribute the 1 over h. Don't. That's only going to make it worse. It's going to make it uglier. So let's start inside and let's get a common denominator. So my common denominator is just going to simply be the two denominators I have multiplied together. And I would recommend don't actually multiply them, just multiply them next to each other. Now, this guy needs the x minus 4, so I'll multiply the top and the bottom by x minus 4. That's going to get me 3x minus 12. The back guy needs the x plus h minus 4 to get the common denominator. Be very careful because you got to distribute a negative 3. Be very careful. So that's going to be negative 3x, negative 3h, plus 12. And then don't forget that's still times 1 over h. All right, so now what's going to happen here is a 3x and a negative 3x, dust in the wind, gone. Negative 12, 12. Dust in the wind. And after all that dust settles, I have a negative 3h on top, and I have an x plus h minus 4 times x minus, and you're going to be so tempted to distribute and multiply the bottom, but don't. It makes it uglier. And I'm going to multiply that by 1 over h. Now, finally, this factor and this factor can cancel, and now I'm ready to find my limit. And I'm going to take the negative 3 over x plus h minus 4 times x minus 4, and now I'm going to find my limit. Now remember, all of this crazy stuff I started with after a whole lot of cleaning in algebra is this. So now I'm ready to find the limit. And when I plug in 0, I get a negative 3 on top, and on the bottom I get x minus 4 squared. Because x plus h minus 4, if I turn that h into a 0, I just get x minus 4 times x minus 4, which is x minus 4 squared. And that is my derivative. So now, let me scroll down just a teeny bit here. Now I'm ready to identify that I have found my derivative, f prime of x. And now I'm ready to go. Sky's the limit once you have that derivative. All right, let's see here. I want to find the equation of the tangent line. Well, I already have a point, 5, 3. And now I need the slope. Well, how do I find the slope? Well, I'm going to come over here. To find the slope at 5, I just have to plug 5 in. So that's pretty easy. And let's see, 5 minus 4 is 1. 1 squared is 1. Negative 3 divided by 1 is negative 3. So my slope is negative 3. So now I'm ready to write out my equation. It's going to be y minus 3 equals my slope of negative 3 times x minus 5. And again, I would just leave it like that. That is an equation for the tangent line at the point 5, 3. So pretty painless, pretty easy to do. All you got to do is a little bit of math, and we're all good at that. All right, stay tuned for the next video that teaches you more that we could do with derivatives.